each function, sketch its graph, and determines intercepts, domain, and range. So for an A, just like last time, we are going to graph the inside first. Put a blue box around this. I'm going to graph this one in blue. And I just want to make a note, common mistake that students sometimes do, is they know absolute values make things positive, but that's only after you've simplified things. So for example, off to the side here, here's the common mistake in its simplest form. In this form, people just get rid of this negative, which is absolutely wrong. But I'll show you why it's wrong. If I would have the absolute value of -1 plus 5, can I just get rid of the negative and make this 1 plus 5 and say it's 6? No. This is not correct. Absolute value bars sort of act like brackets. You have to do the inside first. Only once you get a single number, a -1 plus 5 is the same as absolute value of 4. This is going to equal 4. It's pretty easy to see because -1 plus 5 is easy to figure out that that's 4. And then we do our absolute value at the end. But as soon as we get to algebra, people forget that you have to simplify first, and they get tempted. Ooh, can I just take that negative and make it positive? Can I just take these negatives and make them positive? No. You'd have to simplify first. So we have to graph the inside exactly as it was. So when I go to sketch this, this is a parabola. What do I know about this parabola? Its vertex is at -2, 2. It opens down. So I was going to do this in blue. There we go. -2, 2. Over 1, down 2, over 1, down 2. These are going to be important because these are our x-intercepts at -3, 0, and -1, 0. My parabola opens down like this. And I'm going to graph the absolute value of this over top in green. So again, what the absolute value would do, and if I wanted to, I could easily graph on this another point. I could include y-intercept. If I plugged in 0 for x, I would get -6. All right? The absolute value is going to take those negative y values and make them positive. So on my absolute value graph, I always start with where my y values were positive, they will stay positive. But this point at 0, -6, it will now become 0, +6. And wherever the graph had negative y values, they'll get flipped over the x-axis and become positive y values. So now that we've graphed it, it asks us to find the intercepts. So on our green graph, we have a y-intercept at 0, +6. We have x-intercepts at -3, 0, and -1, 0. Our domain is still everything, and our range, our y values are bigger than or equal to 0. So again, color coding it, I graph the inside first, then wherever my y values were positive, absolute value would keep them positive, and wherever my y values were negative, the absolute value would make them positive, which is like flipping them up over the x-axis. So for B, graph the inside first, which is negative 3x squared minus 1. I'm going to do that in blue again. It's nice we didn't have to complete the square for any of these. The vertex here is at 0, negative 1. It would go over 1, down 3. Over 1, down 3. So I'd have the point 1, comma, negative 4, and negative 1, comma, negative 4. And our parabola is all negative. So then when I want to graph y equals the absolute value of 3x squared minus 1, then my vertex that was at 0, negative 1 is now going to be at 0, comma, positive 1. And 1, negative 4 is at 1, comma, positive 4. And negative 1, comma, 4 is at negative 1, comma, positive 4. So again, it's not the x values that become positive. It is the y values that become positive. And now this, in a green box, is the absolute value graph. Taking that whole graph and flipping it over. So now what is our y-intercept? 0, comma, 1. We have no x-intercepts on this one. Domain is still everything. And our range is bigger than or equal to 1. You can circle 5b, 7b, 10c and d, and 15.